Hello student, from today we are going to start organic chemistry and the chapter name is reaction mechanism. ये चैप्टर काफ़ी ज़्यादा इम्पॉर्टेंट है। क्लास 11 में इसको हम लोग पढ़ते हैं जनरल ऑर्गेनिक केमिस्ट्री के नाम से, और इसमें हम लोग पढ़ेंगे रिएक्शन मैकेनिज़्म। सबसे पहले बात करते हैं रिएक्शन मैकेनिज़्म क्या है। जैसे कि इसका हेडिंग है उससे ये क्वाइट क्लियर है कि किसी रिएक्शन के मैकेनिज़्म के बारे में हम लोग बात कर रहे हैं। नाउ व्हाट इज़ द मीनिंग ऑफ मैकेनिज़्म? मैकेनिज़्म सिंपली मीन्स द डिफरेंट स्टेप्स इन्वॉल्विंग टू परफॉर्म a particular type of organic reaction said to be as reaction mechanism. And what are the main steps involved during any organic reaction mechanism? First of all, reactant molecule undergoes bond fission, and this step is slow step, and it results the formation of reaction intermediate, and these are very short-lived species and exist for very short period of time, which means they have very high energy and they are unstable, and to get the stability they readily react very fast reaction intermediate readily reacts with the reagent, and it finally converted into product. The steps involving like bond fission, which causes the formation of reaction intermediate, and interaction of reaction intermediate with reagent causing the formation of product. The overall process is known as reaction mechanism. Now move on to the next topic, and the topic is bond fission. It is simply understandable by the heading bond fission. Fission means breaking, and breaking of what? Breaking of bond between the two atoms of a given reactant molecule. The bond fission are of two types, one of which is called homolytic bond fission and the other one is heterolytic bond fission. Now, what is the meaning of homolytic bond fission? Homolytic bond fission simply means when the breaking of bond is taking place by the help of heat or light. H nu represent one photon of light. Then the breaking of bond of reactant molecule occurs, and each of the bonded atom acquire one single electron. Here you can see that half arrow, this is the single bond between the two chlorine atom, consists of two electrons, and two electrons are bonded electrons. When we apply the heat or light, the breaking of bond is taking place in such way that it results the formation of highly reactive reaction intermediate, which is known as free radical. तो यहाँ देख सकते हैं क्लोरीन के पास अनपेयर्ड इलेक्ट्रॉन, सिंगल इलेक्ट्रॉन, जो बॉन्डेड इलेक्ट्रॉन्स है वो सिंगली held by both of the bonded atom like this dot represent the electron, and it is known as free radical. Now there is another example of homolytic bond fission. In this example you can see that the breaking of carbon hydrogen bond is taking place, which means the bonded atom are different, no matter whether the bonded atoms are identical or different. When the breaking of bond is takes place in such way, show that each of the bonded atom acquire one single electron. Half arrow means one single electron, and it results the formation of CH3, and this carbon atom acquire one single electron, so it is methyl free radical and hydrogen free radical. This is known as homolytic bond fission, and you must remember that whenever homolytic bond fission occurs for a given reactant molecule, it causes the formation of highly reactive reaction intermediate, which is known as free radical. Move on to the next topic. There is another type of bond fusion which is known as heterolytic bond fusion. This is the heterolytic bond fusion, and such type of bond fusion occurs when the electronegativity of the bonded atoms are different. In this example of CH3Cl methyl chloride, we can see that the chlorine is more electronegative as compared to that of carbon. So it has tendency, the chlorine atom has tendency to attract the shared pair of electrons completely towards itself and result the formation of Cl minus ion, and this is the rest part CH3, and the tail part consists of positive charge. So it is carbocation. Why it is called carbocation? Because the carbon atom acquiring positive charge on it, therefore it is known as carbocation. And whenever heterolytic bond fusion occurs on applying heat, it is very important to remember that it causes the formation of oppositely charged ion. If the carbon atom acquire positive charge, then it will be carbocation, but if it acquires the negative charge, then it will be carbon ion. So the two different types of bond fusion takes place in any organic reaction by the reactant molecule, and due to which it results the formation of highly reactive reaction intermediate. In the given two methods, we understand that the reaction intermediates are the highly reactive species and which are formed due to the bond fusion of the reactant molecule. And why they are highly reactive? Because they have less number of electrons for their central atom than the octet configuration. So the two types of bond, this is very important topic, and this is the reagent. Now, what are reagent? Reagents are the species which are responsible for bringing chemical reaction. So you can note it down from this. The reagents are the species which are main cause of chemical reaction, and without reagent the reaction are not possible. So reagents are the species which are mainly bring about particular type of chemical reaction, and the classification of reagents on the basis of charge are of two types, one of which is called electrophilic reagent. Electrophilic reagents are the reagents which are electron loving. Electro words comes from electron, and filling means having tendency to gain electron. So electrophilic reagents can be said to be as electron loving or electron deficient. If they have deficiency, then they have tendency to accept or acquire electron. Now you can see this electrophilic reagents further classified into two parts, which are charged electrophile and the neutral electrophile. It is interesting to note that reagents are always represented by the symbol E. You can write over here E. So the classification of reagents are of two types. One of which is called charged electrophile, and the other one is neutral electrophile. All the positively charged ions, simply you can say that all cations are the examples of electrophilic reagent. Cation means they have positive charge on them, and which means they are electron deficient and having tendency to accept or acquire the electron from the reagent, and therefore they are said to be as charged electrophile. Similarly, neutral electrophile. These are the electrophile which do not have any charge on it, but they have tendency to accept pair of electron, and this is happen only because of their central atom are electron deficient. So all the electron deficient species like aluminum chloride, beryllium chloride, ferric chloride, all types. Here you can see this, the aluminum chloride, beryllium chloride, boron trifluoride, and the many other examples are known in which the covalent molecule, the central atom has less number of electrons than the octet, and they are electron deficient, and they have a tendency to accept pairs of electron to acquire the octet configuration are said to be as neutral electrophile. Now move on to the next topic. It is nucleophilic reagent. By the heading, it is quite clear. Nucleophilic. These are nucleo word comes from nucleus and philic having tendency to interact. So all the nucleus loving species are the examples of nucleophilic reagent, and these are electron rich and can be represented as Nu. Nu stands for nucleophilic. All the electron rich species are the examples of nucleophilic reagent, and they are further classified into two parts, one of which is called charged nucleophile and the other one is neutral nucleophile. So you can see that all the negatively charged ion like Cl minus, Ro minus, OH minus, and many others are known which possesses negative charge on them are the example of charged nucleophile. Negative charge indicates the electron density is maximum, and so they have tendency to interact with the nucleus because nucleus is positively charged. Move on to the next topic, neutral nucleophile. These are the species which do not possess any charge on them but having tendency to interact with the nucleophile, and this is the only reason they are said to be as neutral nucleophile. All the covalent molecules in which the central atom consists of unshared pair of electron or lone pairs of electron are the examples of neutral nucleophile because they are electron rich species. So in place of statement you can write that all the covalent molecule in which the central atom consists of unshared pair of electron, like in ammonia nitrogen consists of one unshared pair of electron. In case of water, oxygen atom acquires two unshared pair of electron, and there means that these covalent molecules are electron rich and having tendency to interact with the nucleophile. So these are considered as neutral nucleophile. I hope that the very first class of organic reaction mechanism is very easily understandable, and all of you can understand the entire process, entire steps involving in reaction mechanism. So stay tuned with us, and in our next class we'll talk about a very important topic from general organic chemistry, and that is the polarity of organic molecule and as well as the structure of organic molecule. Till then, thank you and goodbye. Have a nice day.